Hello, this is Farhan Shakil from the Republic 2.0, and today's topic that we're going to talk about is the rationalization of surds, which is from the Pure Math 1 and the chapter number 1, algebraic fractions, right? So first of all, before talking about rationalization, we must know that what is a surd. So whenever you're talking about the surd is any non-square number. Surd is any non-square number written under a root, right? Any non-square number written under a root. That is what you call a surd, right? Like you've got the square root of x, or you've got a square root of 2, square root of 19, and similarly the cube root of 9. Something, if this is a cube root, this is a 9. 9 is not a cube. If this is a square root, 2 is not a square number. So whenever you've got a square root, if you're talking about a square root, the number should be a non-square. If you're talking about the cube root, the number should be a non-cube, right? So that is how you talk about the surds. Now, what do we mean by the rationalization? Whenever we happen to come across an expression in which there is a square root or a cube root in the denominator, you need to get rid of that denominator, right? Having a square root or a cube root. For instance, if you're having something like 2 upon root of 3, you need to get rid of that root of 3. So to get rid of that root of 3, whatever you do, that is known as rationalization, right? For example, in this type of a question, you just need to times it by the root of 3 and divide it by the root of 3. And by just doing this thing, you'll end up getting rid of these roots. So you would be having 2 root of 3 divided by 3, right? Now, before getting further into the rationalization of surds, one must know a few rules. How can we manipulate the surds? First of all, if you have got two numbers written within a square root, you can just simply write them like under root a times under root b. Similarly, if you've got under root a divided by b, you can write it like under root a divided by under root b. So for example, if you've got two numbers under the square root, you can times them up like this. If you've got two numbers dividing them up like this, you know, you can write them like that. But students often do mistake that they end up writing under root a plus b also as under root a plus under root b, right? This is wrong. Under root a plus b cannot be written as under root a plus under root b. In the fourth place, under root a minus b also cannot be written as under root a minus under root b. So this sort of a rule is only for multiplication and division. It has nothing to do with the addition or subtraction. Now, for example, first of all, before getting to the rationalization of surd, you guys must understand that how can we simplify a surd? For example, in example number A, if we're having root of 20 divided by 2. First of all, I'm just gonna, split down the 20 and I'll see if there is any square number in it splitting down. So I would end up having 4 times 5 divided by 2. Now I've got the square root of 4 times 5, which I can also write it like root of 4 times root of 5 divided by 2. So I would be having 2 times root of 5 divided by 2. I'll end up cancelling out this 2 with this 2, and I would be having the root of 5 as the final answer. So that is how we can easily simplify these sort of a surd as well. Similarly, if I talk about another type of an example, that example is the root of 2 times 5 minus the root of 3. So you need to times them up. So when you're going to times them up, you would be having 5 root of 2 minus, you can see that both of them are square roots. So you can write them square root of 2 times 3, which is going to be 6. So that is how you must be doing this question. For example, another question that says that you have got 2 minus root of 3 and you're going to times it by 5 plus root of 3. So I just need to times 2 by both these numbers, then root of 3 by both these numbers. So you would be having 2 times 5 plus root of 3 minus root of 3 times 5 plus root of 3. So now I'm just going to times them up. 2 times 5 is going to be 10 plus 2 root of 3 minus 5 root of 3 and minus root of 3 ka square, right? And now I would be having 10. These are the same numbers. 2 minus 5 has to be negative 3 root of 3. And I would be having negative 3. 10 negative 3 has to be 7. So you would end up having 7 minus 3 root of 3. That is going to be your final answer. So that is how we rationalize these surds, right? Now, getting to the main question, we just need to rationalize the denominators. And how can we do that? For example, before getting to the book, let me do a question for you. For example, if you're having under root 5 plus 2 under root 2 divided by under root 5 minus under root 2. That is a fourth example in this video. So you've got under root 5 plus under root 2 divided by under root 5 minus under root 2, and you need to rationalize it. How can you rationalize it? You can just simply under root 5 plus under root 2 divided by under root 5 minus under root 2 and times it by under root 5 plus under root 2 divided by under root 5 plus under root 2, right? So I've just changed this negative sign, turned it into a positive number, and I've got this thing. Now under root 5 plus under root 2 times by under root 5 plus under root 2 would be giving me under root 5 plus under root 2 ka square divided by under root 5 ka square minus under root 2 ka square, right? Because in the numerator I had the same numbers. In the denominator I've got a positive and a negative. So I'm just going to write them like this. Now by opening up the square, I should be having root of 5 square plus root of 2 square plus 2 times root of 5 times root of 2. So now I would be having 5 minus 2, and eventually I would be having 5 plus 2 plus 2 root of 10 divided by 3. So I would be having 7 plus 2 root of 10 divided by 3. So you can see that this was the original expression. And now I end up having 7 plus 2 root of 10 divided by 3. So now you can see that there is no uh, square root in the denominator. And if there is no square root in the denominator, what does that mean? That, we have got something like this. Now, if we get to the book, we've already talked about the surds. After talking about the surds, we were just talking about the rationalization of these denominators. And I'm just going to do this exam styled question. It is question number 5. And in this question, he says that simplify 3 minus 2 root of 5 divided by root of 5 minus 1, giving your answer in the form of p plus q root of 5, where p and q are rational numbers. So we just need to rationalize this number. How can we do that? You can see that in the denominator, there is under root 5 minus 1. So we're going to times and divide it by under root 5 plus 1. We need to change the middle sign. So I'm just going to write that number over here. So the number is, I've got 3 minus 2 root of 5 divided by under root 5 minus 1. And what I'm going to do, I'm just going to times it by, so by rationalizing, I've got 3 minus 2 root of 5 divided by under root 5 minus 1. I'm just going to times it by under root 5 plus 1 and divided by under root 5 plus 1, right? So now I'm just going to multiply the numerator and the denominator. So I would be having 3 minus 2 root of 5 times it by under root 5 plus 1 divided by under root 5 minus 1 times it by under root 5 plus 1. So I'm just going to times them up now. So 3 times root of 5 plus 1 minus 2 root of 5 times root of 5 plus 1. And I'm just going to divide it by under root 5 negative 1 times under root 5 plus 1. There is a negative and a positive. So I can just write a square of these numbers. So I've got 3 root of 5 over here plus 3 minus 2 times 5 and then minus 2 root of 5 divided by 5 minus 1. So now this 3 minus 2 would become just the root of 5, and then 2 5s are 10. 3 minus 10 has to be negative 7 divided by 4. So I can just also write it like negative 7 by 4 plus under root 5 by 4. So I've got the values of P and Q, and that is how you rationalize a number, right? So that was the rationalization of Surds from the chapter number 1 at Excel Pure 1 Math. And I'll be back with the next topic. Until then, thank you very much.